Sauce here. This is a video lesson on translating parabolas. A parabola is a graph of a quadratic equation. The simplest quadratic equation we could call parent quadratic is y equals x squared. And the graph of the parent quadratic is a parabola whose vertex is at the origin. I'm going to make the graph of the parent parabola bold because I'm going to be graphing several parabola on the same axis. What I'm going to be doing to these parabola is I'm going to be translating them, which is a fancy math word for slide. There are 4 directions that we're going to learn how to translate in and how we can affect the equation to slide in those particular directions. The directions are left, right, up and down. We can translate in any direction. We could translate in an oblique direction, but if I was to go or wanted to go up and to the right, then I can think of that as 2 separate translations up and to the right that in combination make a movement in any direction that I wish. So how do we do this? Let's investigate. I'm going to change this equation by modifying x, and then we'll see how the change I made to the equation affects the graph. I'm going to change this equation by adding 2 to x. And you'll note that I added parentheses so that I'm adding 2 before squaring. So I'm modifying x. Still quadratic. But what's its graph? I'm going to see how 1 point moves, and the way that 1 point moves will be the same as all the points. If I put -2 in for x, then I would get -2 plus 2 is 0, and the square of 0 is 0. So if I put -2 in for x, then I will get the coordinates -2, 0, which is the coordinates of the vertex in the new location. Every single point will be affected the same way. Every single point in the parabola will slide to the left by 2. The effect of adding 2 to x means that the graph slides left. Since I have more than one graph on the same axis, I'm going to name this function f so that I can label its graph here. I'm going to write a description for what happened to the parent function when we added 2 to x. It translated left by 2. Let's investigate another change. This time I'm going to change y by subtracting 3. Still a quadratic equation. The modification that we've made to this equation from the parent function is that we've subtracted 3 from y. What effect does that have on the graph? Well, one thing that many people are used to doing is solving for y. So another version of this equation that's equivalent and has the same graph would be y is equal to x squared plus 3. If I put 0 in for x, square it, I get 0, and then add 3, I get the coordinates 0, 3, which is the coordinates of the new vertex after it's been modified or translated. And all of the other points in the parabola, in the parent parabola, will move the same way. They'll move up. This new graph needs a label. I'm going to call it G. And with this function, I'll also write the description of what the effect of subtracting 3 from y had. It made the whole thing move up by 3. Let's do one more. I'm going to take the equation, I'm going to do two things at the same time. I'm going to add 2 to y, and I'm going to subtract 3 from x. What kind of transformation would these two changes in the equation make? Well, there's going to be a vertical change because I'm affecting y, and y is the vertical variable. Adding 2 is going to make the graph go up or down. Changing x means there's going to be a horizontal translation. X is the horizontal variable, so adding or subtracting from it will make the graph go left or right. Many people are used to solving equations for y. So I could show the equivalent equation, an equivalent equation that will have the same graph by subtracting 2 from both sides. These are equivalent equations. I've just made one algebraic change. The graph of these equations are the same. What happens when we subtract 3? We go right by 3. And what happens when we add 2 to y? We go down by 2. If I put in the coordinates or the values 3, or if I put in the value for x of 3, then I'll get x minus 3 is 0, 0 squared is 0, and then subtract 2 from both sides, I will get a y value of negative 2. I've confirmed that this coordinate at 3, negative 2 is the vertex of this equation, whose graph is a parabola that has moved right 3 and down 2. Every point has moved the same way, so it preserves the shape of the parent parabola. And this needs a label. We'll call it H. Left and right are horizontal translations. Left and right movement is horizontal movement. Up and down translations are vertical. Up and down movement is vertical movement. Let's take a look at our examples. Notice that there is a counterintuitive effect in the equation and its graph. Many people look at adding 2 to x and think that you have to increase x by 2, which would make the graph go to the right, but it doesn't. It goes to the left. Similarly, if we subtract 3 from y, we think subtraction means down, but it doesn't. It goes in the inverse direction. Subtracting 3 from y moves up by 3. And so when we have both at the same time, adding 2 to y and subtracting 3 from x, we're going to the right with subtraction and down with addition. There's a counterintuitive nature to the transformations of equations and their graphs.